Hello friends, welcome to this video. In this video I'm going to talk about system of linear equations and discuss their consistency and inconsistency using rank of matrices. Okay, so any system of linear equations can be written in a matrix form Ax equal to b. So suppose you have a system of linear equations which has m equations and n unknowns, then we can write it as Ax equal to b, where A is a m cross n matrix of coefficients, x is a n cross 1 column vector of unknowns, and b is a m cross 1 column vector of constants. So let's understand this using an example. So we have a system of two equations and there are four unknowns x, y, z and w, and these are my constants 5 and minus 10. So then I can write it as a into x. So this is my a, this is my x, and this is my b. So here you can see that it is 2 cross 4. Okay, so there are two equations in four unknowns, and then x has four unknowns, so it is a 4 cross 1 column vector, and when you multiply them you get 2 cross 1, the b part. Okay, so word of caution, while writing this form Ax equal to b, make sure that the constant terms which do not involve any variables in it, you push them to the other side of equal sign so that you can get correct b. So a solution of a system of linear equation is the value of unknowns which will satisfy the equation. So given a system of linear equations, it can have no solution at all. In this case, we say that the system of linear equations is inconsistent. And if it has a solution, at least one solution, then we say that the system is consistent. Now again, if you have one solution, either you can have a unique solution, that is there is only one solution of this system of equation, or there can be infinite solutions. So there is nothing between them. Either you have one solution or infinitely many solutions. If my constants in the equation are 0, that is b equal to 0, the equation is called homogeneous equation, right? And it is of the form Ax equal to 0. Okay, so in this case, when b is 0, if there is a unique solution, that unique solution is 0 solution. Okay, so all values of unknowns will be 0. When there are infinitely many solutions, you get a subspace of solutions. So I would like to reiterate that if b not equal to 0 and you have infinitely many solutions, those solutions do not make a subspace. Only when b equal to 0, the infinitely many solutions will make a subspace. Okay, so now we will see how column space of A, matrix A, is associated with solutions. So suppose C1, C2, Cn are n columns of A. So basically A can be written as C1, the first column, C2 and Cn. Okay, so when you multiply x to A from the right hand side, it looks like x1 c1 plus x2 c2 plus dot 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 xn cn. And since our equation is Ax equal to b, we get this equation. Now it says that my values of the unknowns x1, x2, xn should be such that b is a linear combination of these vectors c1, c2, cn. So for my system to be consistent or to have a solution, it is important that b is in the column space of A. Otherwise, my system will be inconsistent. So based on this observation, we can perform following steps to check consistency or inconsistency of a system of linear equation. So first step is to calculate rank of A and rank of the augmented matrix AB. So what is this? You write the matrix A and then you attach a column B to the matrix, and this is the augmented matrix AB. Okay, so you calculate rank of these two matrices. If rank of A is equal to the rank of the augmented matrix AB, and these two are equal to number of rows in A, that is m, then the system will have a unique solution. If rank of A is equal to rank of the augmented matrix AB, but there is strictly less than the number of rows in A, that is strictly less than m, then the system will have infinitely many solutions. But if rank of A is strictly less than rank of the augmented matrix AB, then the system will be inconsistent. So let's try to understand these steps using an example. So consider this system of linear equations. So I can write it in matrix form like 2, 1, 2. These are my coefficients of x. Then 5, 1 and 1, and then 7 and 1 and minus 1. This acting on x, y, z, and then my b is 52, 9, 0. Okay, so if you can see, my augmented matrix would be my matrix A. This is my matrix A. This is x and this is b, and then I attach b to it, which is 52, 9, 0. Okay, so you can start calculating the rank of augmented matrix, and you can see that since matrix A is attached to it, you will automatically see what is the rank of A. So I will calculate the rank here using row operations. So first I want to create 0 at this position. That I can do by multiplying this row by 2 and subtracting from the first one. So you can see 2 minus 2 is 0, then 5 minus 2 is 3, then 7 minus 2 is 5, and 52 minus 18 is 34. Next I would like to create a 0 here, and again I will just directly subtract this third row from the first row. So I'll get 2 minus 2 is 0, 5 minus 1 is 4, 7 minus minus 1 is 8, and 52 minus 0 is 52. So once I have zeros in these positions, I would like to create a 0 here. So for that I will use the second row, okay, and I'll multiply the third row by 3 over 4 and subtract from the second row. So you can see that 4 times 3 over 4 will be 3, and 3 minus 3 is 0. Then 8 times 3 over 4 will be 6, 5 minus 6 will be minus 1, and then 52 times 3 over 4 will be 13 times 3, 39, and 34 minus 39 is minus 5. So we get this matrix after row operations. So this is my A part, and then the whole matrix is augmented matrix AB. So you can see that from this part, all these three rows are independent, linearly independent from each other, and so rank of A is equal to 3. Okay, and now augmented matrix also, when you add this column, still you have three linearly independent rows, because there is a 0 here and there are two zeros here, so they are linearly independent. So rank of augmented matrix is also 3. And now number of rows in A is also 3. So all these three things are same, so this system will have a unique solution. Okay, and you can easily see what this solution is. So last equation reads minus z equal to minus 5. Then the equation before that reads 3y plus 5z equal to 34, and equation before that reads 2x plus 5y plus 7z equal to 52. So from here you get that z is 5, then you plug here, you will get y is 3, and then you plug y and z here, you will get x is 1. Okay, so after some clarity on this concept, let's try to attempt some previous year problems of JAM. So this question came in 2011. It says that find the value of C such that the following system of linear equation has no solution. That is, it is inconsistent. So we first write the augmented matrix AB, and you'll see that it will be 1, 3, 2, 2, 7, C, then 3, C, 12, and then 1, 2, 3. Okay. So first I will create a 0 here. So I'll multiply the first row by 3 and subtract. So 1, 2, 3, 1. And then 3 minus 3 is 0, 6, 1, C minus 9, and then 2 minus 3, minus 1. Okay. And this will be 2, C, 12, 3. Now I'll create a 0 here. So I'll again multiply the first row by 2 and subtract. So 1, 2, 3, 1. This doesn't change. Then 0, 1, C minus 9, minus 1. This also doesn't change. Then I subtract. So 2 minus 2 is 0. Here I get C minus 4. Then I get 12 minus 6 is 6. and this 3 minus 2 is 1. Okay, now I'll try to create a 0 here. So then I'll use the second row. I'll multiply second row by c minus 4 and subtract from the third. So I'll get 1, 2, 3, 1, and 0, 1, c minus 9, minus 1. Then here I'll get 0, c minus 4 minus c minus 4, 0. Here I'll get c minus 6 minus c minus 4, c minus 9. Okay, and then here I'll get, you are subtracting c minus 4, so 1 plus c minus 4. Okay, so I write like this. So this is the matrix you get. So you have created your zeros here. Now you want no solution, you want inconsistency. So you want rank of A, this part, to be strictly less than the rank of the augmented matrix, whole matrix, right? So rank of A will be less than 3 if you can create a 0 here, right? Then the whole third row will be 0 and you'll have rank 2. So let's solve this. 6 minus c minus 4 c minus 9 equal to 0. So you'll get here 6 minus c square, then minus 9c minus 4c, so plus 13c, and then minus 36 equal to 0. So c square minus 13c, and this will be plus 30 equal to 0. If you solve, this is c equal to 3 and 10. So for these two values, this last row will be 0 in A, okay, and you'll get rank as 2. But if you, now this part is what? C minus 3. If you plug C equal to 3, this will be 0, 2. And rank of augmented matrix will also be 2. So since both will be same, the system will become consistent. So you should plug C equal to 10, okay. C equal to 10 would be my answer, because C equal to 10 will make rank of A equal to 2, because third row of matrix A is 0. But it will make rank of A augmented B as 3, because this last term for C equal to 10 won't be 0, and for augmented matrix rank will be 3. So since rank of A is strictly less than rank of augmented matrix, this system of equation is inconsistent, that is, it will have no solution. Okay, so again a similar question came in JAM 2014. So you have system of linear equation this. Again it is saying that if system we want to be inconsistent, then what can be the possible values for b1, b2, b3. Okay, so let's quickly write the augmented matrix. It is 1, 1, 0, then minus 1, 2, 2, then 2, minus 1, minus 2, and then we have b1, b2, b3. So I'll quickly make a 0 on this position. So this will be 1, minus 1, 2, b1, and then I'll subtract row 1 from row 2. So 1 minus 1 is 0, 3, minus 3, b2 minus b1. Okay, and I keep 0, 2, minus 2, b3. Okay, now I'll create a 0 here. So what I'll do is I'll multiply this row by 3 by 2 and subtract from row 2. So 1 minus 1, 2, b1, first row remains the same, then second row also remains the same, and then I'm subtracting by multiplying 3 by 2, so this is 0, 3 by 2, so this will be 0, 3 by 2, so minus 3 is 0, and 3 by 2, so I'll get 3 by 2 b3 minus b2 plus b1. Okay, so this is my final matrix. So this is my A part, and you can see that the rank of A is 2. Okay, and now if you want inconsistency, this should be strictly less than rank of augmented matrix AB. Okay, so we want to make it equal to 3. It means this part shouldn't be 0. So this expression shouldn't be 0. If you multiply by 2, it says that 3b3 minus 2b2 plus 2b1. This should not be 0 for inconsistency. Okay, so let's check out of these options which one holds true. So 2, 2, 0. So b3 is 0. So 3 times 0 minus 2 times 2 plus 2 times 2. So this is 0 minus 4. So this is 0. So option 1 cannot be the correct answer. Then option 2 is 0, 3, 2. So you get 3 times 2 minus 2 times 3 plus 2 times 0. Again it is 0. So this can't be an answer. Option 3 is 2, 2, 1. So 3 times 1 minus 2 times 2 plus 2 times 2. So you get minus 4 plus 4 0 equal to 3. So this is not 0. So this can be an answer. And then fourth is 2 minus 1 minus 2. So this will be 3 into minus 2 minus 2 into minus 1 plus 2 into 2. So this is equal to minus 6 plus 2 plus 2 plus 4, so equal to 0. So this can't be option. So only option 3 is giving that this expression should be non-equal to 0, which leads to inconsistency. So 3 is the correct answer. Okay, so along similar lines, let's look at this problem which came in JAM 2020. So again, it's asking that look at this system of linear equation and when it will be consistent. So let's write it quickly. This equation is 1, 1, 1, then 1, 2, 2, then 5, m and 4, and the augmented part is 3, 5 and k. We quickly create 0 here and here, so we subtract both of them from the first row and it will become 1, 1, 5, 3, and then 1 minus 1 0, 2 minus 1 1, m minus 5, 5 minus 3 2. This becomes 1 minus 1 0, 2 minus 1 1, then 4 minus 5 minus 1 and k minus 3. Okay, then I create a 0 here, so I subtract from row 2, so I get 1 1 5 3 0 1 m minus 5 2, and then 0 1 minus 1 0 minus 1 minus m plus 5, so I get minus m plus 4, and k minus 3 minus 2, so I get k minus 5. Okay, so this is so we have created zeros here, so now we are ready to look. So let's consider option 1, which is m not equal to 4. So now when m is not equal to 4, this is not 0, okay, and so rank of A is 3, and since this is not 0, no matter what k is, the rank of the augmented matrix is also 3, and so since they are same, the system is consistent. So option 1 is correct. Now let's look at option 2, k not equal to 5. Okay, so if k is not equal to 5, rank of augmented matrix AB, this rank is definitely equal to 3, but then rank of A may not be 3, okay, because what if with this condition we have m equal to 4? In this condition, rank of A becomes 2 and the system will become inconsistent. So k not equal to 5 alone doesn't guarantee that the system will be consistent. So this may not be correct. Now let's look at option 3, m equal to 4. So m equal to 4, you can see that this term will be 0 again. So rank of A will become 2. Now for system to be consistent, you want the augmented matrix rank to be also 2. So this means that k must be 5. So again, alone m equal to 4 will not guarantee system to be consistent. So this can't be a correct option. So now the fourth is k equal to 5. So when k equal to 5, and if m equal to 4 in addition, then rank of A is 2, right, because the last row becomes 0, and since k equal to 5, the last row for augmented matrix is also 0, so for both of them rank is 2 and the system is consistent. Okay, but if k is 5 and m is not equal to 4, then rank of A becomes 3 because m is not equal to 4, last row is non-zero. But then rank of augmented matrix is also 3 because for that also the last row is not 0, and again the system is consistent. So yes, k equal to 5 guarantees consistency of the system. So option 1 and 4 are correct answers. So with that, that is the end of the video. Thank you for watching.